This webinar that you're going to see today is multi-level. We're going to have the views of the Division Chief of Maintenance, Tony Tavares. He's going to tell you why this is important as an asset manager of our state roadway. We're going to talk about some Rick Aaron, who's going to be talking about the headquarters level information about severe duty crash cushions. Then we're going to have a presentation by Troy Bucko, who's at our District 11, who's in traffic operations, who would be one of the persons who would recommend severe duty crash cushions in certain locations. Then we're going to go Rod Lacey out in Kansas, who's in one of the chiefs of the design branch out in Kansas, so he'll talk about how crash cushions are important in the design aspects and what they do out at Kansas. And then we're going to wrap it up with Kevin Killing out in who's a maintenance supervisor out in Nevada DOT, who's actually a person on the ground with people out there fixing and working on these day to day. So it's a very well drafted down the whole gamut of the expertise of this. So hopefully you'll enjoy this. I do have to say a little bit about this. This is sponsored by AASHD TIG. AASHD TIG, the Technology Implementation Group, is a national champion of new high payoff ready to use technologies. They selected our proposal that Caltrans submitted on severe duty crash cushions because TIG wants to showcase the relatively new but growing suite of available severe duty crash cushions. So we're showing why they're useful in high incident locations, why other either superior cost effectiveness, like cycle costs, improve safety of the traveling public, and repair time for workers, and other safeties. A disclaimer, I hate to do this, but you have to do this. It is the way we work out here. FHWA, AASHTO, Caltrans, Nevada DOT, Kansas DOT do not endorse any particular products or companies that may be portrayed. Product names appear in this webinar only because they are considered essential to the objective of the webinar and serve a safety enhancement awareness purpose only. Okay. At this time, I'll go ahead and start the California Department of Transportation's part of it, and I will do that by introducing Tony Tavares, the Chief of Caltrans Division of Maintenance. Tony is one of the technological and implementation champions for Caltrans. Him and his staff are continuously involved in bringing new technologies to Caltrans to help do our job quicker, more efficiently, and more importantly, safer. As a Division Chief of Maintenance, Tony is responsible for over 6,000 employees, a $1.45 billion annual budget, almost 13,000 bridges, and over 50,000 lane miles of roadway. At this time, I'd like to go ahead and hand this over to Tony so he can explain the need for the severe duty crash cushion. Thank you.
Thank you, Joe. Welcome and good morning and good afternoon to those of you outside the Pacific time zone. So I'm Tony Tavares. I'm the Maintenance Division Chief here at Caltrans. And in maintenance, I'm focusing my program's workload based on three simple words: safer, smarter, and together. Safer in that we are trying to ensure the safety of our workers and the public as being our utmost priority. We'll continue working towards minimizing the exposure of highway workers to high-speed traffic and reducing the time our employees are required to work in gore areas. And this webinar is quite timely because just this past Monday evening, we had a contractor employee that was struck by an impaired driver while working in a gore area. Smarter is a word that I like to use. We've all have diminished budgets across the nation. We've had a very difficult time with recessions in our state and across the nation as well. And we've heard the term of do more with less. Well, I like to use the term, let's work smarter, not harder. And what we're trying to do here is look at innovation and look at how we can be more efficient. So we're currently evaluating various high-impact crash cushions that we've installed throughout our state at 190 high-volume traffic areas. Our goal is to identify which products minimize or eliminate the time required for my employees to repair them, while at the same time ensuring the greatest safety for the motoring public and minimizing traffic delays. Last word that I mentioned was together. And the only way we are all going to be successful is if we work together as one team. So we're currently working in Caltrans across functional boundaries with our planning, our design, our traffic operations, and our construction programs to ensure that we deliver projects that incorporate the best asset management principles which allow us to select the right product for the right situation. In addition, together, as we are on this webinar, we're collaborating, we're partnering at various levels of government and industry, and sharing best practices and lessons learned. So safer, smarter together. I hope you can remember these three simple words and that you apply them to your everyday work activities. So today, we're going to be hearing from 3 states on the subject of severe duty crash cushions. And first, I'd like to personally thank these 3 presenters in advance for taking the time out today to share their experiences with all of us. From Kansas, we'll be hearing from Rod Lacey. From Nevada, we'll be hearing from Kevin Killian. And from California, we will be hearing from Troy Bucko and Rick Aaron. The goal of this webinar will be for each state to share their lessons learned and best practices, while at the same time providing some examples such as applying the right crash cushion at the right situation, identifying the time required for maintenance to repair these crash cushions, the durability or life cycle of these various products, and uniformity of using the same crash cushion product through an approved PIF. I want to thank all of you for attending this webinar today. I'm sure you will all come away with some great information on severe duty crash cushions. And at this moment now, I would like to introduce the first speakers. First, Mr. Rick Aaron. He's from my staff. He's a Caltrans superintendent. He's our headquarters coordinator for traffic guidance and safety devices. He's been with Caltrans for over 32 years. And Mr. Troy Bucko is a transportation engineer with the Division of Traffic Operations in District 11, Caltrans, our San Diego office. He is a route manager, traffic safety investigator, as well as a statewide traffic safety systems instructor. He has been with the department for 17 years. With that, please welcome Rick and Troy.
Good morning. This is Rick Aaron. I'd like to discuss Caltrans criteria for crash cushion maintainability. We at Caltrans are trying to establish criteria for the selection of over 30 crash cushions that are currently on our QPL lists. By establishing this selection criteria, we hope to give the tools necessary for our staff and contractors to select the most viable product for the highway conditions. Currently, any crash cushion on our QPL can be selected for projects unless we insert a special provision specifying a particular type. Consideration for approval for use in California currently requires an acceptance letter issued from the Federal Highway Administration for devices that have been successfully crash tested or have been evaluated by the Federal Highway Administration and judged to be equivalent to crash test devices because of their similarity to the original device and meeting Report 350 or AASHD MASH requirements. They also have to be approved from our department's Highway Traffic Safety Features New Products Committee. Caltrans currently has 4 devices approved that could be qualified as severe duty crash cushions. These are the React 350, the compressor, the Smart SC100, and the QuadGuard Elite and LMC systems. As I stated, we have over 30 crash cushions on our highway system, available to be used on our highway system. Caltrans is studying the feasibility and need to further quantify these devices into classifications similar to that suggested in the 4th edition of the Roadside Design Guide from 2011, which are sacrificial, reusable, and low maintenance, and or self-restoring crash cushions. Now in polling maintenance, Caltrans maintenance, most of them would prefer using the low maintenance or self-restoring crash cushions. And this would allow us to use a product that is quickly restorable and or repairable to facilitate the protection of the motoring public with the least amount of worker exposure. Some suggested criteria, Caltrans suggested criteria for low maintenance or self-restoring, the use of low maintenance or self-restoring crash cushions. A history or expectations of multiple impacts per year. If they're going to be hit a lot, it makes sense to put a crash cushion in there that can sustain these hits and have minor repairs and quick repairs. Systems that recover their shape, position, and capabilities after being impacted, or systems that can be easily pulled, reset to recover their shape, position, and capabilities after being impacted with minimal need for additional parts. Sites with repair time limitations, which may include locations within 10 feet of the traveled way, sites requiring night repairs and gore locations, interchanges, and transition ramps. These areas often require extensive traffic control with major impact to the traveling public. We'd also consider repair cost parameters, and thresholds for repair time may be considered, such as $1,000 per impact cost average for repair, or a repair time for a 4-person crew of 1 hour or less. Such criteria may be defined on frontal and side impacts approximating the severity of crash test impacts. Knowing the predominant type of impact, front or side, can help in the selection of the correct type of crash cushion for the site. Reporting of repair cost and repair time results from a yet-to-be-established minimum number of real-world impacts before a device would be formally included in this category may be reasonable. Attenuator types currently being used in high-impact areas that have proven to provide either quick reset time frames, low repair costs, or a combination of these items are the compressor, the Smart, the React, and QuadGuard family. Caltrans always considers the use of new systems that become available. A lot of new technology, and we strive to investigate and see what's out there and what could possibly be better to put on our highways. A couple of examples are the HART and the TAU2. They're up for review and acceptance to this category. I would like to introduce Troy Bucko, who will continue California's presentation.
Troy?
Yes, I'm here. I think you had a connection issue there. I'm Troy Bucko from Caltrans, and I'm going to discuss the 4 systems that we currently have in use for the severe duty crash cushion area. The first is the React 350, and what we have found with the React is that on average it can take anywhere from approximately 15 minutes to up to 16 or 60 minutes to repair. The 15 minutes being on the average when we just have to do a simple reset to our higher speed impacts, which may require more maintenance intensive repairs. Typically, the locations that we have the React 350 installed require a lane closure, and we found that when we have to do repairs, they're on average typically around $700 or less. And for the most part, it's related to the side bracket connections and cables on the device. We found that the React 350 is ideal for locations that cannot be attended to shortly after impact by maintenance. And these are typically areas that have heavy traffic, such as freeway connectors and gore areas. We've also found that frequent device side impacts may require more in-depth maintenance. Typically at higher speeds on the side impacts, the brackets and cabling definitely need to be inspected and sometimes need to be repaired or replaced. We've also had some, although not frequent, but some issues with the potential for rebound after impact. So special consideration should be given when placing near a main line, especially in a narrow gore area or an area where you may not have a standard shoulder width. And we currently have about 390 units available or installed in on Caltrans facilities statewide. Next slide shows some photos of installations that we have had. In these 3 photos, you'll notice we're protecting fixed objects at all locations, but they can be installed in different configurations for that protection. You also notice that all 3 of these devices have been impacted, and the typical telltale of that is the sagging cables on the side of the systems, meaning that they have sustained some kind of impact and need attention. Next system we have is the Smart SCI 100, and this is a test level 3 device, and it does come in different width configurations, but I'm just going to be discussing the 24-inch width. We have found that this device can be repaired in as quick as 15 minutes and typically no more than 30 minutes and has a pretty quick reset time. We currently have 232 of these units installed statewide, and a typical or average repair cost is less than $50. And usually what it requires is maintenance to go out and do a reset of the system and replacing the 2 shear bolts that are contained within the system device. Our average repair cost per impact for high impact locations, meaning where we're getting more than 10 impacts on a device, are less than $100. This has performed very well in areas that will have multiple site impacts within a 1-year period, and we typically look at 3 or more as considered to be multiple site impacts with very little repair cost to the device itself. And we found that the length of the system can be advantageous in short gore areas or areas where we don't have appropriate length for a longer system. This next picture or slide shows pictures of the smart crash cushion. You can see at the top it's showing a fully stroked system after a head-on impact. And then again, 2 lower pictures are showing barrier protection for freeway off-ramps. The QuadGuard family category is, for our department, is all-inclusive. We have not separated out all the devices within the QuadGuard family. Their primary severe duty systems are the Elite and the QuadGuard LMC, and we do use both of those systems. We are moving now towards mostly the Elite system as the LMC is being phased out. The average reset time for these systems is between 30 and 60 minutes and can be as high as 1 to 2 hours depending on the type of impact and the amount of system repairs needed. The average repair costs for our maintenance staff have been about $900 per incident. We have found that the cylinders that are within the system itself have been reusable after most impacts without needing replacement. And we're not sure how many of the Elite and LMC systems specifically we have, but we have 190 of the QuadGuard family systems installed statewide. And this is a picture of the QuadGuard Elite system that has been impacted and what that looks like post-impact. And again, typically this would require a maintenance reset and inspection of the system, and may at times require a replacement of one of the side panels and the front nose plate. The last system is the compressor, which is a fairly new system for Caltrans. Our average repair time has been between 15 and 30 minutes for the systems that we do have installed. And some resets have been done as quick as 5 to 10 minutes with the maintenance going out and having our law enforcement agency do a traffic break for them to be able to get in there and pull that system out. The average repair cost has been approximately $700 per impact. It's a shorter system length as well, and it has proven useful in areas where we have a length or a constraint within a gore area. We've also had repeated impacts on these systems with minimal or no repair other than just a simple reset. And it has a good redirection upon site impacts with a minimal damage to the system. And Caltrans currently has 39 of these systems installed statewide. This is a picture of the compressor, and you'll see one that's just installed without being impacted, and the second one is a location up in District 8 that is being pulled out after a full head-on impact and being reset. And you can see there's not a whole lot of damage to the system. The ultimate goal of the department is to come up with some type of life cycle cost analysis to be able to determine the best devices for different field locations. And this is just a graph showing how we'd like to do that and accomplish that. The department currently does not have any policy or process in place to determine life cycle cost. But what we have done is taken our maintenance cost of the system and known repair times and kind of come up with a general basic working frame for moving towards a life cycle cost process within the department. At this time, I'm going to pass it over to Rod Lacey at Kansas DOT.
All right. Thank you, Troy. Good information. Kansas DOT, we've experienced a need for severe duty impact attenuators. A little bit of knowledge about or information about me. I've been with KDOT approximately 20 years. Currently, I work as the engineering manager for the State Road Office. Have done work as a designer, project manager. Have a little bit of time as a construction and in the construction and maintenance field as a metro engineer. I currently serve on the AASHD Technical Committee for Roadside Safety, and one of our objectives is to produce the Roadside Design Guide and serve on several other NCHRP roadside safety projects, and a member of the AASHD Subcommittee on Design. In Kansas, we have history with a lot of the similar devices that the other states have indicated. You can see the list there. Predominantly what we have on our system now are the QuadGuard family of products, some tracks and the SCIs with a few reacts in test locations. As everyone here knows, each of these devices has their own set of pros and cons, and the DOTs are trying to find a way to come up with several devices that will meet our needs and provide a good life cycle cost while providing a safe product for the motorists that hit them and the guys that have to go out and fix them so they can get in and out of traffic. When we started down this trail to develop a severe duty crash cushion, we wanted to get a device that was robust, designed, and avoided any complicated systems with parts that break easily or that are difficult to install or maintain. System survivability, so if that unit gets hit, I know it'll work and I don't have to go out and tear that unit out or fully replace it. And reliable confidence in repair parts and efforts to make repair. By that I mean, it's good that our guys, when this thing gets hit, they know when they're going out, almost all of the time, they can have the parts available and ready to repair that unit in a timely fashion. Another issue is more products are used, an issue becomes with storing stock parts or stocking the parts or ordering them and getting them in a timely manner to make repairs. And acceptable in-service performance to us, that's a real key element. All of these devices will go through the crash testing to get certified or found acceptable for use. However, how they're actually performing in the field is a key element, and as part of that, we look at the repair cost and, more importantly, what our maintenance staff find and the difficulty to repair or keep in service. One of the other concerns that we have in Kansas where we're using these are typically in high-volume traffic locations where there's changing geometry, or the locations where we'd be concerned with the distance that a vehicle may rebound after striking a crash cushion. So to do that, we went through an effort to come up with our severe duty crash cushion. And to do that, we analyzed the repair cost on our different crash cushions that we have in the Kansas City metro area. We also evaluated the crash test results, and by that we go in a little deeper than just finding out that it met the 350 or MASH criteria, but we get an idea of what parts were damaged, what were some of the other issues with each of the crash tests, and try to evaluate that, how that compares to what we typically see with our crashes in our state. We reviewed the FHWA acceptance letters. Those are very helpful. And then once we had all this information, we used that to do a cost-effective analysis to come up with a tool to help us select devices that would go into our severe duty category. And we approached that from two different methods. We looked at ADT, so many vehicles per lane that would warrant a severe duty crash attenuator. And then we also looked at our 10-year life cycle cost based on the units that we have in place. And what we found after going through that in our public interest finding for severe duty crash cushions, crash-prone locations such as a gore, location where there's a historical crash rate, and for the data that we found in Kansas, where that rate exceeds one hit every 10 years, we found that a severe duty would be cost effective. High-speed, high-volume roadways with directional traffic, more than 6,000 vehicles per day per lane. At this time, this is our current pre-qualified list of products that are available on new construction or reconstruction products. So the contractors will select whether it's a TL3 or in a severe duty location. You can see at this time the SCI is the only device we have in that category. As new devices come around and we're studying them and going through that cost-effective analysis, we will add products that we feel are appropriate to put into the list based on some of those parameters I explained. Here's just a couple examples. The photos may not show up real well, but the one on the left is a pretty significant highway location where two interstates separate. So that is a location where we'd want a severe duty unit. And the other one is a high volume ramp, on-ramp. Future severe duty devices in Kansas. As we continue to look at all of the products that come available on the market as manufacturers develop new devices to meet our needs, we'll look at, make sure they have acceptable crash performance, and the devices that have reliable, consistent repair characteristics so that our folks can get out there and repair them timely and cost effectively. Obviously, as Tony mentioned at the beginning, our budgets are all constrained and we need to find ways to maintain our system and keep it safe for the user. So we need to put out devices that provide that acceptable life cycle cost. And more importantly, devices that are uncomplicated to repair and provide safe operation after the repair. Our maintenance workers get exposed to the enormous traffic volumes, and the motorists are also exposed to all the construction equipment out there making the repairs. Lessons learned. What we found to avoid wide transitions, this would be on new construction or reconstruction where we could design the facility to eliminate the need to install all the wide panels to go to a wide obstacle, such anything wider than 36 inches, say an elevated ramp where the two barriers come together. If a person can design that in a manner such that they get it down to where a standard crash cushion will fit, they'll experience upfront lower cost as well as reduced life cycle cost and reduce the complexity of the system. We've used some products in the past where we had some issues with the amount of maintenance and work that was required to get these operational again. So we want to make sure we're selecting units that expedite maintenance and reduce exposure to the motorists while it's being repaired. Real important is to select units that are uncomplicated to inspect and make repairs. Our guys, when they're looking at these, they need to be able to look at it and have an idea whether that device needs to have pieces replaced. And what we found is on all steel products, such as the SCI, they're very easy to inspect, and the determination of reuse or acceptable service life of composite materials is more difficult for our field staff. One thing we're working on right now is developing maintenance guidelines similar to what we're doing for our new construction or reconstruction so that we have metrics in place to let us know when to upgrade these devices to a severe duty unit. And understand the amount of damage to the device during crash testing and subsequent in-service performance. That way we can make a logical determination on a severe duty device. With that, I'm going to turn it over to Kevin Killian.
Thanks, Rod. My name's Kevin Killian. I'm a Highway Maintenance Supervisor 2 here in Las Vegas working with NDOT. I was asked to be a part of this team because apparently I have some specific knowledge about a couple of these severe duty crash cushions that everybody thought that would be of some interest to you guys. With that said, a little bit about me real quick. I'm a Highway Maintenance Supervisor 2, like I said, working in District 1, Las Vegas. I'm responsible for all nighttime maintenance activities currently in Las Vegas with 4 crews under me. 14 years of experience working with various crash cushions, either installing, repairing, or removing them. Started with NDOT as a maintainer back in April of 1999. I've promoted through the ranks to my current position about 2 years ago, overseeing, amongst many other things, the repair and maintenance of several crash cushion systems in our inventory. I'm directly responsible for 38 highway maintenance workers working on Nevada roads at night. That's kind of my primary driving force behind this. NDOT, I can really only speak for Las Vegas area. I've talked to a few people throughout the state to get their opinions, and I've kind of worked that into my presentation here today. But my primary experience, let's say, has come from what we've personally experienced here in Las Vegas. NDOT owns and maintains several hundred crash cushions that are in use in Nevada roads all over the state. Survivability and lifetime costs seem to be the main factors used to determine the type of system that they install. Life cycle cost is the preferred way here in Vegas. Main consideration for me is getting the crews in and out as quickly and as safely as possible when resetting or repairing a system. Nothing is more important to me than the safety of my people. So what should we think about when we're deciding what kind of system we want to install or use? System survivability is pretty high. You know, you don't want to have to go in and keep repairing this thing and putting tons of money into it. Ease of repair or reset, the easier the better. It's the KISS method. Repair parts availability and cost. You need that stuff on hand right now when you need it. You can't be waiting for weeks to get it. Training of personnel to accomplish the inspection and repair needs to be simple. Obviously, like I said before, life cycle cost. Impact on the drivers that use the system. Not only the impact what drivers get when they hit it, but think about the impact to traffic for the next 3 or 4 days until maintenance can get out there and reset the system. Time exposed to traffic during repairs. Again, my most important thing with the crews, get them in and out. This slide shows our crash cushion inventory, what we consider our standard duty crash cushions. In the inventory is a quad guard. We do have a few great systems left. We have a few Tau 2 systems out there. We have a few ADM systems throughout the state, and we do have, or at least had, a React 350 installed in Las Vegas. The only one that's considered a severe duty crash cushion right now is the Smart TL3. That's the SCI TL3 system. Currently, only the Smart Cushion Innovations SCI is installed in the Las Vegas area as a severe duty crash cushion. We started using it when we were replacing some of the other systems that had fallen off of our QPL, or we were having problems getting parts for some of the other systems. Kind of started using it as a universal replacement. It's worked out pretty good. Since no other severe duty systems are currently installed in Las Vegas, data on repair and performance is simply not available. So I'm not going to discount any of the other systems that are out there. I just don't have the first-hand knowledge, and I don't think it's fair to try to condemn them or prop them up if I don't have that information. NDOT always continues to evaluate new systems as they're introduced to the market. We consider them for placement on our qualified products list and possible inclusion on the severe duty classification. Guidelines. When I first got this position, what do they decide, or what do they think for a severe duty location is? Nobody could give me a real good answer. I had some people tell me, well, you know, the places that get hit a lot. And that's pretty simple, but I finally narrowed it down to this description. The engineering description is locations on a high-speed, high-volume roadways where the posted speed limit or 85th percentile speed is greater than or equal to 55 miles per hour, and the directional traffic volume meets 25,000 AADT in District 1 and District 2, which is basically the Las Vegas and Reno areas, and 12,500 AADT in District 3. That's more the Elko areas, Elko and Ely, and a history or an expectation of multiple impacts each year. Sites with repair time limitations, locations with within, it should be 10 feet or less of the traveled way, sites requiring nighttime repairs and gore locations, or in the case of new construction or alterations, or where there is no crash history to base a decision on, we would analyze the site with a similar geometry or conditions as locations meeting the above criteria. So that's the engineering official NDOT way to look at this. So SCI is obviously the predominant crash cushion in Las Vegas. Why is that? Well, when we were talking about it, we needed a system that was made of components that can survive the harsh environmental conditions of Las Vegas. Anything that's made of plastic in Las Vegas or wood simply just doesn't last. You go through one summer and things get brittle that shouldn't be brittle. Things get soft that shouldn't be soft. So we needed something that could survive the 120 plus degrees during the summertime and the minus 32, not minus 32s, but under 32 degrees in the winters. We really wanted to try to narrow it down to one system because it reduces the confusion. If you have two systems or multiple systems that have similar parts but maybe not exactly the same parts, we find that maintainers go out and they might mess up a repair. That's not good. It opens us up for liabilities. The manufacturers actually don't want us to mess up their systems. They don't want them to perform poorly. So the simplified training was an easy thing for us to look at. Ease of repair, obviously. Again, that's an in and out quick kind of thing. We don't want to be out there having to use cranes and bulldozers to fix these things, in and out. In the case of the SCI, we actually produced a small toolkit which has all of the necessary tools to effect a reset on an SCI system. It has the shear bolts that need to be replaced almost every time that it's hit. It has the anti-rotation pin pullers. It has the screwdrivers, hammers, the correct size wrenches, everything that's needed. And this is kept in most of our supervisors' pickup trucks. More about that in a little bit. The ability to repair or reset during the initial accident call. We're talking about budgets again. It's really an important thing for us not to have to redo work. So we want to be able to fix these things, and if we can fix them quickly during the accident even, before Highway Patrol takes off and opens up the road, we're leaving a better system for everybody. That leads to reduced downtime. Minimal out-of-service time to the traveling public equals a safer highway system. It's ready for the next guy that can't control himself and runs into it. We found that 15 to 30-minute repair or reset time reduces the exposure of the people working on the system to the hazardous high-speed traffic. Lifetime cost, especially in locations that see high hit counts with the SCI, has proven to be extremely good. The experience with the SCI system has been extremely safe and easy to work on, relatively inexpensive system to reset. I have a goal to reset any damaged SCI systems prior to the accident being cleaned up. That's important. Prior to the accident being cleaned up. How many other systems can we talk about that we can fix those before the accident gets cleaned up? Of course, a few things have to happen to get that done. This is accomplished 90% of the time currently if we have crews on duty and we are notified in a timely manner. If there's a trained supervisor on duty during our after-hours calls, it's often quicker to repair the system than it is to barricade or place a cushion truck at that location and wait for another day to repair it. That has been pretty amazing. So the cost of the system initially is $18,500 initial cost system. The system can be reset numerous times with proper inspections and maintenance. We've had SCI systems that have been reset 20 plus times without any major repairs before they show signs of needing to be replaced. Maintenance forces have installed about 80 of the TL3 systems in the last 5 years. Most of those I've been involved with personally in one way or the other. Mostly to replace older systems that have been removed from our qualified products list or simply have just gotten outdated. Contractors have installed an additional 50 or so in the Las Vegas Valley on various projects in the same amount of time. We've averaged at least 3 resets per week in Las Vegas. Over the last 4 years, we've had to replace 7 units because they were damaged beyond repair. 7 units because they were damaged beyond repair. We had one that was hit with a roto-rooter truck. Highway Patrol estimated the speed at over 90 miles an hour. It did damage it beyond repair. The other 6 were damaged when the tow truck drivers pulled the vehicles off either sideways or had some reason to catch the bottom rails on the system and bent it to a point where we didn't feel comfortable leaving it in service. Those are the only ones that we've had to replace, though. We found it to be less expensive to reset the system in most cases than it is to drive to the maintenance yard, to retrieve barricades, and return to the accident scene when trained employees are available to effect a reset. Typical repair time we found is about 20 minutes for 2 workers. Repair parts most commonly needed are shear bolts, which cost about $3. Approximately 50% of the time we would need to replace a nose plate, which costs about $100. Major repairs, about 10% of the time we would replace a fender panel. We've replaced 30 of them in the last 6 years. Cable replacement, we've had 8 cables that have failed that we've had to replace, usually due to being hit 15 or 16 times. Hydraulic cylinder replacements, we've never had a failure. So continuing a 10 impact cost history of one location, I pulled information on one single location for 10 hits. This is actual money that was spent. Cost to the taxpayer total, including the initial install, was $28,705. That's parts, labor, manual labor, equipment, the whole 9 yards for the life of the system. The average repair cost was $1,070. Again, this includes parts, equipment, labor, benefits, traffic control, time to and from the shop. It was the biggest number that I could come up with. The average parts cost was only $123. We had a couple of side panels that needed to be replaced. This location received 10 impacts in 4 months. If we used any other system, the parts cost alone would have been over $60,000. That's a savings of about $58,000. The system is still in place and working as designed today. We're up to 12 hits as of last night. With that, I will turn it back over to Joe.
Thank you, Kevin. Rick, Troy, Tony, Rod, Kevin, thank you for your presentations. Appreciate that. At this time, we're going to go ahead and take the questions over here, and I'll go ahead and start that. Do we need to take phone questions first, or do we want to go straight into the compiled questions? Jennifer?
Let's see if we have any questions on the phone. Thank you. Ladies and gentlemen, if you wish to ask a question, please press star then 1 on your touch-tone phone. You will hear a tone indicating you have been placed in the queue. A voice prompt on your phone line will indicate when your line has been opened. You may remove yourself from the queue at any time by pressing the star key followed by the digit 2. If you are using a speakerphone, please pick up the handset. Once again, please press star 1 at this time. And we do have a question in the phone lines. We'll take our first caller. Please state your name.
Hi, my name is Edgar Herrera. I'm in District 7, Los Angeles, in California. Work for Caltrans. We have a situation in which we've been selecting the SCI smart cushions, but we have to have a public interest finding memo done. We also have to have a proprietary use memo. And I'm just trying to make sense in why the SCI crash cushion will be the best choice for our severe duty areas. Especially we have gores on really busy freeways where we're selecting this. And do you guys have any input that I could use into justifying the use of this besides the ease of repair and besides the cost?
This is Rick Aaron. One of the things I would like to say is it's not necessarily the preferred one. We use 4 different ones in here in California, and any one of those 4 would be good. I think one of the determining factors that's important, and one of the things we're looking at to quantify and qualify these units as severe duty, is the ability to take multiple hits. If it's an area that sustains multiple hits in a fairly recent time frame, possibly before maintenance can get out and pull that unit back out, you might want to go with one of the other ones. You know, it just depends on the circumstances and the area where you're talking about it. It's kind of a situational need. I mean, we've got several different cushions that meet.
Right, but we also have a kind of a constriction in space. It's kind of a small gores that we're using this for.
Well, there were several of these that qualified in small gores. The SMART, the compressor, I believe even the REACT can be used in a small gore. So, again, it's a situational need.
This is Joe again. For your question here, this is more of a project specific for Caltrans. I think we need to help you because there's certain contract requirements on this. If you can send your information here to us, we'll go. If you can contact me by email, I will get you in contact with the right person to help you with your public interest finding, or if you determine if you want to just do the best of three through your contracting status.
Okay.
So if you could do that, because the thing is, that's a very specific, project-specific, location-specific question that we better handled outside of this group. If that's okay with you.
That's fine. That's great.
Anyone else on the phone?
Not at the moment. I'll just remind everybody it is *1 for questions.
Okay, so we'll go up here and do the questions. I'll start up here. The first one we have a question from Dwayne Bennett. What defines an attenuator as severe duty in California? Rick, you want to field that one?
Yeah. Well, currently we really don't have a definition to define severe duty in California. That's one of the things we're kind of working on doing, is trying to get the 30 that are on our QPL list defined so that we know what situations are best to use them. As far as defined or severe duty, we kind of go by what the feds are saying. You know, they in the fourth edition of the Roadside Design Guide, they have some criteria in there, and we're kind of looking at that to model what we're trying to do.
And also to follow up on that, we do have what's called the Highway Safety Features New Product Committee. It's a group in Caltrans that takes a look at new products and evaluates them and before we accept them onto the Caltrans, onto the state highway system. And as part of that, they usually make a recommendation if it should be used for what the proper use of that piece of equipment is. So these four that were listed here have been vetted by our Highway Safety Features New Product Committee as being applicable for severe duty. So that's why they're listed here. The next question, let's see, it's from Janie Can, Florida, FDOT, Miami. Are those systems self-restoring? And I think someone already gave an answer to this. The REACT 350. Actually, Troy, why don't you go ahead and answer it so people on the phone can get it?
Yeah, sure. Of the four systems that we discussed, the only one that's not considered a partially self-restoring device would be the SMART SCI. The other three devices would be considered partially self-restoring and may sustain an impact after a primary impact, a secondary impact as well, under design impact conditions.
Okay. The next question from Arizona Division. Have you seen an increased number of hit-and-run incidents because the systems reset themselves? Does this cause a delay in being notified when a location has been hit? I'm going to go ahead and shoot this one over to Troy.
Yeah, I guess there's kind of two ways to look at that scenario. And we do know that some of the systems, and we have the most systems with the REACT, do get hit, and we may not be notified by it. But the other side of the story of that is that then that means that driver's probably driving away from that incident and not having to call some kind of emergency personnel to assist. So there may be a little bit of delay, but most of our maintenance staff are out on their designated routes daily and doing inspections and checking the systems. And then we have a policy to go out and inspect the systems every so often as well, regardless if there's been an incident or not.
Okay. The next question is from Bazad Zadiji. Are those approved devices to be used in Caltrans? I guess this goes back again with Troy, but it's still the same answer, correct, Troy?
Yes, all four systems are approved for use in California.
Okay. There was a question by Wad Winterlin. and I think this is for Rod. The question is, why is the Tau 2 not rated as severe duty in Kansas?
I'd have to go back and look. That's about 3 years ago we did our calculations, but I imagine it has to do with the cost to repair the parts. And at the time, there was no in-service performance evaluations conducted. So those are the type of things we'd have to reevaluate before we add units to that category.
Okay. Thank you, Rod. The next question from Dwight Wonderland. Do any of the severe duty need to have tracks cleaned or annual maintenance? You want to handle that one, Rod?
Sure. That's a pretty loaded question, and, to me, all roadside devices need maintenance of some sort. People need to go out and look at them. That's one of the concerns I have with the notion of low maintenance or no maintenance, because all units, after they get hit, they should be examined to make sure that the parts and pieces are still operational, and the occasional look to make sure the tracks and all the fittings are still installed or in place correctly. To me, that applies with any roadside device.
Yeah, I would have to agree. You got to maintain these things, even if they have a track or not. It depends. I mean, you can get tire rubber underneath them, or sand, or dirt, or anything like that. You got to be watching them. That's what our maintenance forces are out there doing.
And on the FEI or similar products, when we reviewed the crash test, we noticed the tracks don't get damaged in their crash testing. I'm not going to say they never do, but they take a lot of side impacts, and the units still operate acceptably. Those are the types of things we look at when we make our determination on severe duty. And typically, the amount of debris that may get in there are not going to slow down these devices, any of them, unless it's just blatant stuff that's piled in there and no one's paying any attention to the device. But I think that would be very unusual to find units where there's so much debris in them they won't work. I'm not going to say that hasn't happened, but I think that would be very unusual.
Okay. Thank you, Rod and Kevin. We have a question from Oklahoma DOT. How do you determine the high impact area? By past accident history, geometry, or ADT? I'd say in California we use all three, and I think for the same with Nevada and Kansas. Do you agree?
Yes. We actually looked at, reviewed the accident reports every time our maintenance guy, I shouldn't say every time, but most repairs, there's a report filed, and they go out to fix them. So we evaluated that information to help us come up with our life cycle cost.
Yeah, I agree 100%. We check them, and we do report back. A lot of that is word of mouth from the supervisors to me, and then I talk to our people in the line.
I'm going to go ahead and jump down to a question here. This is from Dwight Wenderland again. Any concern for ice or snow buildup in or around the devices, and what effects have these have on the safety devices? Kevin?
I got a little bit of information from some counterparts up in the Reno, Carson City area. We have a few of these that are up in snow country, and I have been told that there is no effect whatsoever, that it's covered enough by the device itself where the sled actually rolls, that there hasn't had any ice build up or anything like that that's stopped it.
Continuation of Dwight's question. He has a question about why is the need for covers on the REAC? It's just to keep debris out, snow, rain. That's the answer for that. And the next question again from Dwight is the buildup of debris, dirt, sand, trash a concern? And I think that's already been answered a couple of times. It is a concern with all highway devices that you need to keep them maintained and clear of debris so they work properly. With that, we're going to go ahead and go down to the next question from Habib Tamori. Which one of these systems perform better with side impact? Okay, I'm going to give a Caltrans answer. The Caltrans answer is they all work for it. We don't rate which one's better, best, or better. I'd almost say you'd go back, if you have a concern about it, you would actually look at the FHW letters and the crash test results to see which one would fit best to the location you're using it with. But for all four that Caltrans uses, they all meet the site impact requirements and work very well. Rod, do you want to add anything to that, or Troy?
You hit it well, Joe. You know, part of when we did our life cycle cost analysis, we were able to gather that information based on reviewing the actual accidents and then getting an idea what the damage is to those units that we were using. And then we compared that to how the device did in the acceptance crash testing as well as in-service performance evaluation.
The next question, Oklahoma DOT, how does your state specify sole source on severe duty impact locations? Oh, wow. Actually, this varied. As a design engineer up in our district, when I was a design senior for them, we did at certain locations do a public interest finding for like a one-time location to put a severe duty crash cushion in because of the geometrics and also the materials that are out there. So we do that, but it's a case-by-case public interest finding. Very difficult to do, but you know it's usually used when warranted by the engineering need. We usually try to keep it where we give the option of at least 3 different items that the contractor can provide is what we prefer to do. And having 4 crash cushions has helped us a lot with that. Rod, you use just 1 crash cushion for sole source. Does anyone else for severe duty impact locations specify besides how I say it? We do at Caltrans?
No, we don't have a sole source agreement yet in NDOT, but I found that when we talk to our contractors when they're doing the initial install and the initial design, that the price on the systems that our design people want is usually not that much different than what they can get on another low bid, and so I haven't really had a lot of problems with contractors coming in and trying to put a system in that we didn't want in any locations. They've been pretty good about working with us.
Okay. The next question is from Eric, no last name. How many crash cushions are installed beyond 10 feet in Las Vegas? Any idea, Kevin?
Beyond 10 feet from the traveled roadway, I'm going to assume is what I would say very few. Most of them, you know, if it's more than 10 feet, we're looking at like a guardrail in treatment kind of situation. So I don't have an exact number, but most of the attenuator systems that we use are on the off ramps or transition ramps. We do have a few and some collector ramps here on the freeways, and all of those are for the most part within 10 feet of a road, one way or the other. Gore situations is kind of the biggie.
Yeah, I'd agree with that. That'd be like a freeway connector for us if we have something out there maybe a little bit past 10 feet in Caltrans. John Mountainer, FDOT, how do you differentiate between self-restoring and reusable? Troy, you want to try this one, or should it be Rod?
Sure. We can both probably take a shot at it, but typically, and self-restoring is kind of there's a big word with that, but it's the 3 systems that we have that are partially self-restoring, meaning that they may be able to take a second impact after that primary one, are typically the devices where we're not going to have to spend a lot of money to go out and do repairs after that initial impact as well. So they kind of fall into the same category with the low cost as well. Any of our standard devices probably are going to take repairing at least half of the system and quite a bit of maintenance and labor time to go out and do those repairs. So those categories are outside the severe duty.
Okay. You know, I passed up a question. I'm going to go back to it real quick. This is from Nick Artemovich. I should get that right. I've read this many times. FHWA headquarters. He had a question of, is anyone disqualified any particular attenuators because of poor performance? I do know disqualified means pretty much, my understanding, would be removed from the QPL, the qualified products list. In Caltrans, we have the Highway Safety Features New Product Committee, and when someone submits a new product such as a crash cushion or an end treatment, it's reviewed. And sometimes we have failed, we have not adopted it for use in Caltrans because either the crash test results or not having a need specifically for those devices. Though I don't have a list of which ones they would be, if Nick, you're interested, I can be more than happy to try to find that information out for you. But because we tend to look at everything over a lot in Caltrans, because since we are a state that gets sued a lot, we tend to make sure that everything's proper before we allow it onto the highway system. Okay. I'm going to go down here. Let's see. The last question was...
Joe, just a second.
Yeah.
It's Kevin with NDOT. We've had 2 that have come off of our QPL in the last 10 years.
Oh. Do you know the 2 that came off?
The Trax family from Trinity and the Adium system just got pulled.
Oh, that's new.
Yep. That was this week, I believe.
Well, thank you. That's news to me. Okay. Let's see. The next question. Where was I? It's self-storage. It's Eric again. No last name. How often should crash cushions be inspected, assuming that it has not been hit?
I can speak partially for Caltrans. If we know systems aren't being hit, we're usually doing them either biannually or annually for the most part, or during our normal course of inspection of a facility. They'll go out and do a specific inspection of a type of device. So.
Now, Troy, that's a specific inspection. Now, Caltrans, normally, though, we have the supervisors out there in his truck that's driving by and doing visuals on these, normally weekly. So, you know, we have a cursory inspection, and we have the annual or other or biannual thing that we looked at.
That's correct, yes.
Okay. Let's see. Mohammed Ghanum has a question. What is the cost of each system? On this one, it varies by location. I know in Caltrans we might pay more than what they pay in Nevada. I don't know why, but that just happens to be the case. I would say the best thing to do is probably just, should we defer this to a Google search? I'd say that's probably the best way of doing it, or contact a local vendor.
Yep.
Unless someone has a number they want to throw out there.
Well, I don't know enough. I can tell you that we're paying contract price for the SCI right now, and the Quad Guard family is dependent on how many bays, so it varies from 20,000 to 36,000. The Tau 2s, I think, we're in the 14 to 20,000 range. I don't have hard numbers, though.
Okay. Next question from James Ostrich. Curious if Caltrans or other states recover repair costs from errant driver insurance. Caltrans, you want to go ahead, Rick?
Yeah, we definitely, if there is a responsible party determined, we definitely bill back, yes. If there's nobody, you know, if it's a hit and run and they're gone, we can't, obviously. But if there is a responsible party and they're noted by the CHP, we definitely bill them.
Is that the same for Kansas and Nevada?
Yes, Nevada bills for them as well. Typically on an SCI repair that's less than $100, it's hard to do the paperwork because it almost takes more state funds to bill them than it does to just pay for it. But we try to recover every penny that we can from a responsible party.
Okay.
We've actually had some people want to countersue saying their car wouldn't have got damaged if we didn't have a device there.
Yep.
Yeah, I've seen that comment.
Why were they driving there in the first place?
Yeah, well, that's why we put them out there.
Okay, this is Monique Burns for Nevada. So you've installed over 130 SCI systems in the last 5 years, and only seven had needed to be replaced.
As far as I know, I can tell you for sure that 7 in Las Vegas have been replaced because I've been the one that's either ordered the replacement of them or done the inspection on them. As far as I have gotten from my counterparts in the northern part of the state, they have not replaced any. So yes, I stand by those numbers.
The next question is Michael Thompson. The question, does high heat affect the life or performance of cylinders in the REACT system? I think this is actually two-part because it's actually heat and also the UV exposure we've seen. I'm going to go to the heat guy on this. Kevin, you want to take this question?
Yeah, I'm not a scientist, and I'm not a plastics engineer, and I'm not a chemist, but we were finding microfractures on the REACT cylinders on the one system that we had installed here in Vegas, and the vendor would not assure us that it was 100% good to have those small microfractures. It was didn't seem to be as prevalent in the wintertime, but during the summertime we had difficulty pulling that system back out, and they attributed that to possibly the heat. In that specific location, it was kind of before my time. It was probably about 7 years ago, and the decision was made at that time to replace that system. So that's why we don't have any REACT 350s in town right now.
Okay. The next question from Ted Whitmore. Where partially self-restoring devices are used, does the current criteria for their use take into account the area available to accommodate the rebounding characteristic of those vehicles?
I know in California.
Okay, Rick, you want to go ahead and answer this one?
I know in California that our traffic safety engineers, we've been doing a study where we're replacing a lot of attenuators with the severe duties, and that is one of the criteria they take into account. Definitely.
Yeah, we consider a rebound. That was one of our criteria when we developed our severe duty, and as we continue to evaluate future products, rebound characteristics will be a key component.
Nevada as well, we take that into consideration. Where our REACT was that we had 7 years ago, I understand that was also a considerative part of why we removed it, because we just didn't have the real estate to allow a vehicle to rebound as much as it needed to.
Okay, next question from JDS. How many impacts on SCIs has Las Vegas experienced in Las Vegas? How about Nevada experience in Las Vegas?
I'm not sure if he's looking for total impacts.
I want to give an annual?
I'm sorry?
You want to give an annual or a monthly? Or?
Well, I've had 5 this week, and it's Thursday. That's pretty normal. I would say on average 3 to 5 per week on the ones that we have in town. So if you extrapolate that out over 52 weeks, maybe 300 to 400 a year. What was the other part of the question? Yeah, just that. Yeah, that's 300 to 400 per year probably.
Okay. Let's see. Andrew Rayner, do any of you have a maintenance program specific to the different systems?
As far as a specific maintenance program, no. It's real simple. When it gets hit, repair it. Inspect it before the repair, make sure that it's going to be safe to put back in service. If it's not safe, then we start talking to our engineers to see what we need to do as far as either replacing it, redesignating that location for a different type of system, or we go through that risk management stuff and try to figure out what we want to do with it.
We do the same thing basically here in California.
Thanks, Rick.
Kansas does the same.
Okay, the next question is from Stephen Machalski. Does anyone have any experience with self-resetting attenuators rebounding vehicles back into traffic post-compression?
I think we hit on that one before. Yes, there was some concern with that.
I think the answer is concern. We've never, I don't know if we've had any accident history to say we've had a larger secondary accident from it. But that's just from what we hear from what comes up. But it is a concern. The rebound is a concern that engineers need to take a look at before recommending which crash cushion should go into which location. But nothing specific that I can say, hey, it's caused major accidents in the LA area.
And hey, John, I'm not sure if he may be meaning after it's been impacted once, and it still may be impacted a second time if there's any rebounding on that second impact before it's actually been reset.
Okay. That's the answer to the question. Do you want to add on to that, Troy? I mean, I'm not sure what...
Yeah, I was going to say, if that was the case, then I'm not aware of any on a secondary where it still hasn't been reset where we've had any, but we have had a couple instances on the primary impact.
Okay. Got a question here from Brian Hadley. Would it be possible to have Caltrans maintenance crews available 24 hours a day to repair a crash cushion during the accident cleanup? Highway patrol presence, like is done in Las Vegas, so the SCI smart units would be fixed quickly and then used more instead of the reaction compressors. Rick?
I can take that. We are available 24 hours a day, but we can only respond if we're called. Oftentimes the CHP doesn't, depending on the type of damage or if there is minimal damage, they don't call us out. We have very little control over that. We're trying to educate them that it is important that in the case of any attenuator hit, we need to be called. But we can't guarantee that. I mean, that's in place. It's always been in place, but we can't guarantee that the CHP are going to comply with that. We try. So, and even if they did, it wouldn't necessarily guarantee that we would use reacts or compressors or smarts more. It depends, again, on a case-by-case basis where the location is as to what type of attenuator we use.
Thanks, Rick. The next question I like, Nick Artimovich, FHWA headquarters. Are the manufacturer repair guides adequate for your people to do their job right? Rick?
Pretty much, yes. And if we have questions, in my experience, we've had no problem getting information from the vendors if we needed it. But yeah, for the most part, they're pretty on, at least from my experience with my folks, yes.
Rod?
Yes.
Do you agree with that? Any issues with...
I agree with it. I think sometimes folks may get a little, have a little reservation about repairing something, getting in there when they've got all these different parts and pieces on different systems. That's probably the biggest thing I've seen. And I don't, on some of the self-restoring, I don't know if it's been an issue in other states, but one of the concerns we have is if they're collapsed but they haven't released that energy they have stored, I believe there's some special procedures in letting that pressure off, if you will, on these self-restoring cushions. So that's one thing I think needs to be pointed out to our maintenance folks so that we don't have a device release quickly and hurt one of our workers. So I don't know how well that's understood by the folks doing the maintenance.
Okay.
And then when a device should be replaced, getting a definitive answer on, the lifespan of certain pieces. So it's somewhat vague sometimes.
Kevin, did you want to chime in with the repair guides?
Pretty standard, yeah. All of the vendors that I've dealt with have been very good about sending us not only the repair guides, but if we needed the extra help, we would have a representative on site for any of the systems that we've worked with. And those people have always been very knowledgeable about their systems. I've never had a problem being able to get a hold of somebody during regular business hours. We have had to put off a couple of repairs because we've had questions or something in the middle of the night. We had to get an answer during the day. But for the most part, once we have some people who've got a couple of repairs under their belts, the systems have kind of gotten down to a point where they're very simple to work on. It doesn't take a whole lot of training or expertise to get in there. We can train a new guy on repair of most of these things within one or two repairs.
And the vendors too, in my experience in California, they're pretty, if they're willing to come out and give training whenever asked. There's never been a problem with that. If there's new staff, because we get turnover. So if there is new staff, and we've never had a problem with contacting a vendor and them being available to come out and give us training or via videos or even bring out a model of it and show us things. So it's been pretty good.
Yeah, that's our experience in Kansas too with all different roadside products. The vendors are usually very good about responding to questions.
Yep.
Let's see. That's all the questions I have in the compiled questions list.
I wonder if we have any questions over the phone. We have no one in the queue at the moment.
Okay.
Okay, great.
Well, with no more questions, I don't see anyone typing either. I wanted to thank you for your time, and thank you for attending this webinar. We hope you find it useful. I did notice that Jennifer put down that this webinar will be available on the website, I don't know, in a day or weeks, I don't know, but it will be available on the NHI website. And we'll also have some information on the AASHD TIG website for severe duty crash cushions is also there. Again, I want to thank my presenters for coming out here and doing all this work for me. They did an excellent job, and I thank you for your time, and I hope you have a great day.
Joe, this will also be posted on the Highways for Life website, and it usually goes up on the Highways website sooner than it does on the NHI. It'll be up within the next 2 weeks on the Highways for Life website, and that's www.dot.gov/HFL.
And I also posted that there in the chat pod, so you can all get that there.
Thank you, Jennifer.
Thank you, Byron. Thank you, everybody. That does conclude our conference for today. Thank you for your participation and for using AT&T teleconference service.